All right, welcome back, Physical Science 20. So with this, C equals N over V. We did an example in which we knew what the moles of solute is and volume of solution in liters. So that was the first example. And then we looking at when I know the molar concentration, I know the volume, so looking for moles, and then from there I can change to mass. And the last one here will be, we'll be given a mass or moles, so we'll have the solute. We'll have the molar concentration, and then figure out the volume. So fructose, C6H12O6, is a natural sugar in apple juice. A person with diabetes must be aware of the quantity of sugar he or she consumes. If the molar concentration of fructose in a certain brand of orange juice is 0.670 moles per liter, what volume of apple juice contains 35 grams of fructose? So if we look at the rationale here, we know we know the molar, so whenever you have moles per liter, or big M for molar, that is the molar concentration. It tells us how many moles per liter I have. N, we kind of know 35 grams, but of course we need to have how much moles that is. So of course that's going to involve figuring out the molar mass, and then volume, that's what we're looking for. So with our little schematic here, we know C, we know N, kinda, like we have to convert mass into moles, and then we'll be able to solve for V. So first of all, we have to, maybe we'll do it down here, so the molar mass of fructose. So let's work it down here. So for every 1 mole of fructose molecules, I have 6 carbons, 12 H's, 12 moles of H, and 6 moles of O. So carbon's 12.01, hydrogen's 1.01, oxygen's 16.00. So of course, that is going to give me, let's see, 72.06, and 12, and then 96.00. So 180.18 grams per every mole. So that's what goes up here. That's the molar mass of fructose. So grams and grams cancel. That's going to give me 0.194250 moles. So I now know what N is. So C equals N over V. 0.670 equals 0.194250. Again, don't round off just yet. Equals V. Now you may remember a rearranging trick from math. If our unknown is on the denominator, we can interchange it with what's on the opposite side. So V equals 0.194250 over 0.67. So that is going to give us 0.289925 liters. Now if I look at my numbers here, there's 3 sig figs, 3 sig figs. So I'll go 3 sig figs, 0.2. Now this is a 9, so that 8 and 9 is going to get bumped up to 90. So 0.290 liters is what we get. And on the next page, there's a couple of more things about concentration we need to look at before we leave concentration. Preparing solutions. So many chemical reactions involve aqueous solutions. Often these reactions are conducted quantitatively, so with numbers, amounts. In order to give reliable data, it's important that the solutions be carefully prepared with known concentrations. A solution of a known concentration is called a standard solution. So let's highlight this whole thing. So a standard solution is one in which we know its concentration. In the lab, standard solutions are often prepared using volumetric flasks. What are these? So they're kind of wide at the bottom, kind of a pear shape, and then a narrow neck at top, so that we can add a little bit in, some solid, some liquid water, shake it, and then top up to the line, whether it's 250 mils, 100 mils, 1,000 mils, etc. Volumetric flask is a pear-shaped container with an elongated neck. Each size of a volumetric flask is designed to contain a certain volume of solution, plus or minus 0.1 mils at a specific temperature, often 20 degrees C. Solutions, so how do we pair, this is kind of outlines how you make a solution. So solutions are paired by first dissolving the known quantity of solute that we need. So doing a similar calculation that we did on the previous page, figuring out how many grams that we need to make a certain amount of liters with a certain concentration. So we would know what we have there. So we'd take it and we place it in the flask. So we put it about 1/4. So if we know that the top is right here, we'd maybe put a little bit of water in there, mix it up to dissolve that liquid, and then add it until the bottom of the solution's meniscus. So if this is the neck, we know that it makes a meniscus shape up top, so we want that to be at the line. So if this is 250 mils, let's say, the bottom of the meniscus has to be touching it, not the top. The final volume of standard solution prepared is in figure below, shows us 250. So you can see here the meniscus, so it's right on that line. That's how you do it. It may be difficult to transfer the solid directly to a volumetric flask. If you had a funnel, that would make it easier. So sometimes it's first poured into a beaker with a little bit of liquid, dissolve it, and then pour the liquid into there. Finally, add the water until the bottom lines up with the calibration mark. All right, so that is it. That marks the end of 2.5 concentration. It also marks the end of the FC2 unit. So with that, you should be able to do the assignment for this, and we'll see you again.